Okay, section 8.3 is identical to 8.2, only now we're going to use the t-test instead of the z-test. So this is just like chapter 7. In 7.1 we used the z-chart, and in 7.2 we had to use the t-chart. So this is where we don't know the population standard deviation, or sigma. So we only know sample, which is your sample. Again, this is more likely, but unfortunately it's not as precise as what we just did in 8.3. All right, so your t-score is going to look like this. X bar minus mu, that doesn't change. The only change is it's s over the square root of n rather than sigma over the square root of n. So everything else is still the same. All right. When you do this, when you find your critical values, just like it was in chapter 7, your degrees of freedom is n minus 1. Okay. Now, the t-chart is still easier to use, most people think. If I can find one, here we go. What you have to do, though, is now you have to look up here, and it says one tail or two tail. So the hard part is you don't split it in half. No matter what, when you look at this chart, you don't have to split it in half. Most people still draw the picture, but just don't put the percents like we were doing. And again, you'll see it when I do this. So if it's one tail, you're going to use this row along the top. If it's two tails, you're going to use this one. All right, so the other thing is it only gives you the positive numbers in here. So if it's a left-tailed, you're going to have to do the negative numbers. Okay, so we're going to practice this. Find the critical t-value for alpha equals 0.05, sample size is 17, right-tailed test. So again, some people don't do it for these just because you don't need to put that up there, but you can if you want. Your degrees of freedom is going to be 16. All right, so what you look at, this is one tail. Since it's a right-tailed test, one tail, 0.05 is going to be here, down to 16 gives us 1.746. Okay, that's the only difference from what we just did in 8.2 is now you have to use this chart instead. Okay, this one is a left-tailed test. Degrees of freedom is going to be 22. Again, most people don't even write that down, but if it's helpful, that's fine. So left tail means one tail. So we're going to go over here, 0.01, and down to 22, 2.508. But notice it's over here, so you have to remember to put negative 2.508. Okay, so only positives will show up in the chart, so you need to know whether you need to put a negative with it or not. All right, the last one is a two-tailed test. And 0.1. So again, you don't split it into two. You look here, it says two tails, 0.1. You don't look at the 0.05. All right, two tails, 0.1. So in this one, you will always use whatever alpha is. You don't have to ever split it. Just know if you're one tails or two tails. So two tails, 0.1. Degrees of freedom is going to be 18. So 1.734. And then also negative 1.734. So you have to remember if it's a left tail or two tailed, you need to add that negative in there with it. Okay, so that's the only thing that's going to look different. Everything else right here it says is the same 5 steps as the z-test that we did in 8.2. So here we go. A medical investigation claims that the average number of infections per week at a hospital in southwestern Pennsylvania is 16.3. Random sample of 10 weeks had a mean number of this, standard deviation of this. The reason we know, other than the fact that these are 8.3 notes, is it does not say the word population in here. Okay, so if you, that's what you're going to look for in your homework and your test. If you see the word population standard deviation, you use the z-chart. If it does not say population standard deviation, you have to use the t-chart. Okay, that should say infections. Is there enough evidence to reject the investor's claim at 0.05? Assume it's normally distributed. Okay, so this one right here, investigator claims it is 16.3. So this one already looks different. H sub 0 mu equals 16.3, H sub 1, it doesn't say greater than or less than, so not equal to 16.3, but this one is going to be our claim because it says the claim is. All right. Step 2. Again, I still draw it because, again, I like to look at the shaded region, but totally up to you whether you do it or not. So this is 2 tails, but still using 0.05, that's the hard part, and degrees of freedom is going to be 9. So 2 tails, 0.05, degrees of freedom is 9, 2.262. And then also negative 2.262. So again, if you don't want to draw the picture, just put CV equals plus minus 2.262. Step 3, instead of Z equals, we're going to have T equals X bar, so our sample mean is 17.7 minus the 16.3 from step 1. Standard deviation is 1.8 over the square root of 10. So 10 goes here, 9 goes there. Should end up with 2.46. So that would be over in the shaded region. Therefore, we need to reject H sub 0. So that means we think this one is true. So there is not enough evidence to support the claim that the average number of infections is 16.3. Okay, now if you wanted, most people just get in the habit of writing that. Technically, the question says this: is there enough evidence to reject the investor's claim? The answer would be yes, there is enough evidence to reject his claim. Okay, I prefer this one honestly because it gives a little bit more detail, but this technically answers the question, so it's up to you which one you would rather use. Okay, next one. A physician claims that a jogger's maximum volume oxygen uptake is greater than the average of all adults. Sample of 15 joggers had a mean of this and a standard deviation of this. So again, it doesn't say population in there. That's why we have to use 8.3. It says the average of all adults is this. Is there enough evidence to support the claim at alpha equals 0.05? So, step 1, H sub 0 mu equals, right now, we think it's 36.7. Okay, so this is the sample mean. This is what the mean is right now. H sub 1, it says that he thinks, or the physician, I'm just going to say he thinks it's greater than the 36.7. And that's his claim. Even though it doesn't say the word claim. Oh, it does say claim, sorry. So yeah, that one's easy to figure out. Step 2, drawing the picture. Greater than, your degrees of freedom is going to be 14. And we're looking at 0.05. So this is one tail, 0.05 down to 14. Right there, 1.761. Step 3, T equals 40.6 is what they got from their sample, minus 36.7. Standard deviation was 6 over the square root of 15, and we end up with 2.52. So that's obviously over here. So we're going to reject H sub 0. All right. So step 5 then, again, I'm going to write it out and then we'll go back and answer the question. So we reject, which means this is true. So there is enough evidence to support the claim that joggers have a greater maximal volume oxygen uptake, whatever that means, than regular adults. So it says, is there enough evidence to support the claim? Yep, that's what we answered. So we're good to go there. All right, one last one of these is where we have to do all of the calculations ourselves. So hopefully you remember how to do that from chapter 7, but if not, I'll go through it with you. So again, here we have the data. We have to figure out everything on our own. So we need to know what X bar is, and we need to know what S is. So you hit the Stat button, Edit. You probably have numbers up there, so go up, Clear, Enter. Then we can type them in. 60, Enter, 56, Enter, 60, Enter, 55, 70, 55, 60, 55. Stat, over to calculate, one variable statistics. Again, I can just hit enter. Some of you have to work your way through it. We'll use 58.9. Oh wait, this is money, so let's do 58.88. And then 508. All right, so step 1, H sub 0, mu equals. So without even reading the problem, I can do that part of it, because that's what it's always going to be. So it says, educator claims that the average salary of substitute teachers in school districts in Allegheny County, Pennsylvania is less than $60 per day. Yikes. So there's 60, H sub 1 is less than, and that is the claim. Less than means over here. Your degrees of freedom is going to be 1, 2, 3, 4, 5, 6, 7, 8. So n equals 8. Degrees of freedom is 7. So 1 tail, 0.1 down to 7, 1.415. But since we're over here, we need to put negative 1.415. Step 3, t equals x bar 58.88 minus 60 over 508 divided by the square root of 8. Negative 0.62, so that would be over here. So we do not reject H sub 0. So again, even though our calculations showed it is less than 60, it's not significantly different. Okay, so that's why even though, yes, our 8 people showed that it was less, statistically it is not significant enough. So step 5, there is not enough evidence. So we're not rejecting this, meaning we think it's true. There is not enough evidence to support the claim. That the mean salary of substitute teachers is less than $60 per day. Okay, there's the end of chapter 8.